Okay, so this problem is also find the area. We want to find the area enclosed by those quadrilateral below. So we want to find this area, this area for this region. Okay. Oh, sorry. So for such a problem, we just use the same idea. We just say this equal this rectangle, this square. Okay. So minus, let's say minus this one, right? So like this rectangle or this square is this. Let's say the length is 1, 2, 3, 4, 5, 6, 7, 8, 10 like. So this equal 10 times 10. So minus this one. This equal this one. This right triangle is half. So here's 1, 2, 1, 2, 3, 4. 4 multiply 1, 2, 3, 4, 5. And minus this one, right? This one is half. So this is 1, 2, 3, 4, 5, 6, 6 multiply 10. Okay, so minus. So this one we put this as two parts. This. Okay, for this one, we also put this into this rectangle. This rectangle is 3 multiply 1, 2, 3, 4, 5. Multiply 5. So minus this. Minus. So this triangle is half 3 times 1. Right? 3 times 1. And then minus this one, right? This right triangle, so equal half. This equal 7 multiply 1, 2, 3, 4, 5, 6. Okay. So we just need a little bit calculation. We can find the answer. Okay. Okay. So for this problem, quite the same. We use the same idea. The area for triangle ABC equal. We just this equal this right triangle. So suppose we put this as a D, like ADC. ADC is half of 4 times 4. So minus this. So suppose I put this as a E minus A is B. Minus A is B. So area is 3 times 2. Okay. And then minus this EDCB. So EDCB, we put this into two parts. Into this rectangle. This rectangle is 1 times 2. So, and minus this is half of 1 times 1. So for this problem, also this same idea easy. Like we want to find this ABD. ABDF. We want to find this area. So this area equal rectangle minus this triangle, right triangle, this right triangle. right? So this one, such a problem by now is easy to us. Okay. So now let's check this problem. It says we have a square with area 4. So this means the length is 2 by 2, like this 2, 2. So its area is 4. This square is inscribed in a square with area 5. So this is a little bit big. Like, so this square is this length, let it go 5, right? Okay. So we just put so with one vertex of a smaller one on the side of a larger one, large square. So the graph we can use this like, okay, so this is large one, this is smaller one is like this small square. Okay. Okay. And this is larger one. So suppose this is A, so this side B, so this is A, this is B, so here this is A, this is B. So we put this, okay, so we can like from a large square we can make some smaller square. Okay. Okay. So here we need to find A and B. So let's say so we can make an equation. So there's such a problem. It looks like equation problem. We don't know A and B, so we need to find them. So the first we say A plus B equal, let it go 5, right? And this here A and B, so this side 2. So other equation is A square plus B square equal 2 square equal 4. So we can have those two equations. Okay, so here from those two equations we can find A, find B. But the question is we just need to find A times B. We just find AB. What is AB? So here we need a small algebra. So suppose this equation is 1, this equation is 2. So let's check this equation 1 square minus equation 2. What we can get? So we get this A plus B square minus A square plus B square, so equal, let it go 5 square, which is 1. Let it go 5 square, 5 minus 4 equal 1. So this is A plus B square. We have the A plus B square equal A square plus B square plus 2AB. Okay, so we find 2AB equal 1. Okay, so then AB equal half. Okay. Okay, so now we check some problem related to the circle. Okay, so circle. So we have such a circle, and so we call this is the center of the circle, and this is the radius of the circle. Okay, so we have some results about the circle. So maybe we should remember and use them. So the first we say this O is cent. So suppose here is AB, so we can make this angle AOB. So we can call this as arc and center angle. But anyway, what's the name? We don't care. Saying so here we have this angle APB. So what is the relationship between these two angles? So we have this, because this angle is 2 of the angle APB. Okay. And we also have this, like let's say, like so this APB. So if we change the P to here, okay. So let's say AQ, and this APB and AQB is the same angle. APB equal angle AQB. So if they face the arc, the same arc, then we know this is the same. Okay. And for, let's say, so this angle D, ADC's face this arc, like ABDC, and this arm for this angle faces ADC. Put them together, they make a whole circle. So we have this result. We say this angle alpha plus this angle beta equal 180 degree. Okay. Okay. So for a so-called outside circle, let's say suppose we have a circle. Okay. From outside 1 point, we can make a tangent line. Okay, and so here we have tangent line, and so we can the second line. Okay, so here this okay, tangent line means this is large angle, right? So here we have some result. We say, actually in general, let's say, in general we have a circle, okay, and here outside the point, if we draw 2 lines, okay, okay, so suppose there's a P, there's A and a B, and here C, the D. So we have this result. We say PA, let's say PA multiply PB equal PC multiply PD. Okay. So a typical situation, if this PT is tangent line, so we say PT times PT square equal PM times PN, or equal PA times PB, PB. PT square equal PA PB, also like PT square equal just equal PM multiply PA. Okay, and yeah, so this we call this is second theorem. Like here, this second theorem, and if the tangent line PT, then we call this as a second and a power theorem, or just we can regard there's a typical situation like PT. If the tangent line, then only this line here, this line intersect this circle for 2 points. So if there's a tangent line, So only 1 point, right? So I think this is basic things we should remember. PA times PB, or secant, so we call it secant theorem. PA times PB equal PC times PD. Okay. And for diagonal, we also have this result. For here, with this so-called, so we have, so we just pick 4 points. So we have this like A times C plus B times D equal this diagonal D1 multiply D2. So this A times C plus B times D equal D1 times D2. So this, we call this a diagonal theorem. Okay. Okay. So now let's check some problems. Okay. So at the first, also we need to say like for area, for so-called, we have this formula, pi r square. Pi r square. So suppose this is r. So pi r square. And this I'm sorry. This circumference of circle is 2 pi r. And we also call this r is radius, and this is a diameter. Okay. Okay. So at first, we check some problem related to area. We want to find area of a circle, but not a whole circle. Like this is so easy, right? But this is very easy. Like pi r square. They will not ask you to find area for this circle. So the question usually is so-called cut off, like partial of circle or something like that. So let's check this problem. So this is in the finger show. U is this segment, this line, and UT are line segment, each of length 2. So we put okay. So this is 2, this is 2. And angle TCU, the TUS is 60 degrees. This is 60. Okay. 60 degree. So arc TR and SR are each 1/6 of circle with radius 2. So what does this mean? It's like we have a circle with radius 2. Okay. Okay. So this is 1/6 of them. So 1/6. So this means this angle is 60, right? That's okay. So then we need to find the area. What is the area for region? Sure. What is the area? Okay. So let's say at the first we connect this ST. So then this STU, this one is equilateral triangle. So 60, 60, 60. And this side also 2. Okay. And let's say, so this one is, let's say, a circle. Suppose this is a circle. Let's say this is sorry, such a circle, right? Such a circle. So center is here. So such a circle. So this, let's say, the center. This is 60. Okay. So if we extend this to this, okay. So this is 60. Okay. and so here same. Okay, so we know our extend this. So this is the center of this circle, and this also 60. Okay. Okay. So now we get the idea. So we know this area just equal. So we put this as, let's say, here so we just RST. We just put some number. Suppose this is A and B. Okay. So the area we need to find is SAS. We need to find this area. So equal this triangle ABU minus this minus this 2, right? Okay. So we know so there's a 2, yeah. So what is the area for, let's say, we area for triangle ABU, this area equal, so this area, let's say, so here we need to find this area for this, like 4, 4, 4. What is this area? And so we need to find this height. Okay, so we say if there's 2, so those things maybe we should remember the typical right triangle, right? If this is 1, this is 2, then this is radical 3. Okay, so we know this is, if this is 4, then this is 2 radical 3. So there's 2 radical 3. Okay, so the area is half times 4 times 2 radical 3, so equal 4. Cancel the 2, 4 radical 3. Okay, and then minus this a so-called or 1 of 6 circles, so actually 1 over 3 circle, right? Because there's 2 same. So 1 over 3 of this so-called pi r square, r is 2. So this equal 4 over 3 pi. So the answer should be equal 4 radical 3 minus 4 over 3 pi. Okay. Okay. So this problem says a circle of radius 2 is cut into 4 congruent arcs. The 4 then the 4 arcs are joined to form a staffing shell. Just make it like that. So the question is, what is the ratio of the area of staffing to the area for ordinary circle? So ordinary circle we already know like this is 2. So this circle is this is easy, just equal pi r square is 4 pi. So in order to find this ratio, we just need to find this area. So area for this. Okay. So this arc is just like this arc. So we just okay. So this and the same, right? Okay. So we know we wanted to make this as like this. Okay. Okay, so we know this area equal this square minus this this arcs. Yeah. So this four arc put together is just this the circle. So we know this equal here. Let's see. This is two. Oh, this is 4. Okay, so this square is 4 times 4 square. So minus this 4 pi. Okay, so that's equal 4 minus pi, or just the 4 minus pi, right? Okay, so the ratio is equal this over 4 pi. Yeah, so we can cancel this 4, so equal 4 minus pi over pi. Okay, so this is a so-called the radius 1 is inscribed in a square, and circumscribed about another square. So we say, so this at this first connected. Okay, so this is 1. So we have this square radius 1, and then we can have this small square and this big square. Not big, yeah, big square. Okay, so the question is, which fraction is closer to the ratio? So we need to find the ratio of the so-called shaded area to the area between the two squares. So we need to find the ratio for the two areas. So-called shaded area. So so-called shaded area meaning source, right? Let's say source. So we can find this. So what is this? So this is equal to the circle minus the square, right? So this is pi r square, 1 square, minus what is this? The area for this square. So we know, so we can regard it as this is equal 4 of this large triangle, right? 4 large triangles. So this large triangle is half of 1 times 1. Okay. So this area is pi minus 2, right? Okay. And the ratio is so close to the area between the two square. So between the two square is just the big square minus small square. So that area is just equal. We have 4 of this. So here's 1, 1, right? 4 of 1, 1. So just half this area, half 1 times 1. So that's equal 2. Okay, so the ratio is pi over 2 minus 2 over 2, right? This ratio is the so-called shaded area. Yeah. So this one, the question is close to which number? So we can say like pi. So which pi is roughly we can say pi is 3.14. 3.14. So 1.14 over 2. So just like so just close to, I think close to half, right? Okay. Okay. So we stop here.